So there's a bunch of properties of logarithms that you need to keep in mind, and those are these ones right here. Now, these come from things like, they come from the corresponding properties of exponentials. So like, for example, if I have a to the m times a to the n, then that's a to the m plus n. Okay, or if I have a to the m raised to the nth power, that's a to the mn. Okay. Now, this first property of logarithms, it plays off this one, where you're multiplying, you have a log of multiplying two numbers. That's the log of the first number plus the log of the second number. This one would be like if you had a negative exponent, that would be a to the m over a to the n. That would be that one. This is like the power rule. This last one, so this one would be kind of like that one would come along here. So you have here, you have this power c, and that goes down in front like that. Well, actually, we don't really need to make any. We don't really need to like talk about. I'm just telling you though that these properties come from the properties of exponents, and we don't need to really get into that. For the exams and stuff, you can make sure that you have this handy. You have these rules handy that you can be able to apply them. Okay. So let's go ahead and start the exercises. So start with number 1. Okay, so here you have the log base 4 of 16 times 64. So this would be, A would be 16 and B would be 64. So that's the log base 4, the little a is 4, of 16 plus the log base B, wait, this should be A. This should be an A right here. I don't know what it should be. Well, that should be an A is also, I don't know what's wrong. Okay. This is log base 4 of 64. Okay, so that should be the answer to that one, because it's 16 times 64. So you split it up into log base 4 of 16 plus log base 4 of 64. Okay, so 16, 64, 16, 64 right there. And the answer to the first part, okay, so it says the logarithm of a product of two numbers is the same as the sum of the logarithms of these numbers. So this is the sum of the logarithms. This is this logarithm of a product. It's equal to the sum of the logarithms. Okay, here, number 2, the logarithm of a quotient, that would be the second rule here, of two numbers is the same as the difference. So that would be difference. So this one is log of base 4 of 16 minus log base 4 of 64. Oh, it's the same answer as the first part. And then part 3, or number 3, the logarithm of a number raised to a power is the same as that power times the logarithm of the number. Okay, so this, it's being raised to the 18. 18 is the power. So this is equal to 18 times log base 4 of just 16. Okay, number 4. We can expand this to get what? Okay, so what you do here with number 4 is, first of all, it's a quotient, so we use this rule here. So it's a log base. The log, it's without a number, it's just the common log, which is base 10. So don't write the number. So using the quotient rule first, then use the product here. Then finally, we use the power by bringing the 5 down in front. Okay, and that would be the answer right there. Okay, and then it says we can combine 5 log x plus log y plus log z to get, so here this is going back the other way. Well, one thing you can do is you can notice that this is the same as that, and you just write that as the answer right there, log of x is y over z. But you can, or you can do it by steps. You can go take this x and take this 5 and put it up there. I mean, that's just the same as this one right here. And then combine these two. And then by the product rule, by this rule here, and then by this rule, just do the final step. And there's your answer. Okay, let's look at number 5. Okay, so 6 log x plus log y minus log z. You're supposed to combine that into one logarithm. And I guess that's just the same as what we just did. So so first of all, you want to take the powers up. Do that first. Okay, then you start combining stuff. Now, if you have a log plus another log minus a log, and they're all the same base, then you can just go ahead and skip all the way. Put the ones that are positive up top or that are pluses, and then put the minus one down below, like that. And that should work. Except that's the wrong answer because, I don't know, I mysteriously changed this 6 to a 5. Okay, so that should work right there. Okay, number 6. Oh, number 6 is a fill in the blank. And that features this last one, which come on. That features this last one. This is known as the change of base formula. Okay, so you have log base b of x is equal to, you can do this with any base. You can choose any base a. Of course, it has to be a positive number and not 1. Log base b of x is the same as log base a of x divided by log base a of b. Okay, so the x goes in the, so you're taking the log of, the x goes in the numerator, and what you take, and the base goes in the denominator, and you put a new base there. Okay, that's the change of base formula. Okay, now, number 6 says, most calculators can find logarithms with base 10. I'll just write the answers. And base e. To find logarithms with different bases, we use the change of base formula. We use that formula. To find log base 7 of 16, that's this right here, we write the following. Log base 7 of 16 is equal to, okay, now here they're choosing the common logarithm, log base 10, over log of 7. Okay, so the 16 in the numerator, the 7 in the denominator. Okay, so that's one answer. Those are answers right there. And then they're having us calculate that. Okay, so what we're going to do is we're going to go to, I'm going to show you how to do this in GeoGebra. So let's see here. Let's go to GeoGebra. So we just go to the calculator in GeoGebra. Okay, so you can type log of 16 divided by a log of 7. Okay, and that's going to be the answer. 1.425 will be the answer. Now, the question number 6 says most calculators can find logarithms with base 10 and base e. Okay, well, nowadays they can find it with any base. So remember, the objective was to find. If you do this, you type in log and then you hit the underscore key, like if you're putting a subscript, and you put 7. Okay, that puts that 7's a little bit lower, and then you come back out using the right arrow key, and then you put a 16 inside. Then that's going to be that just does it directly. Okay, 1.425 directly. And the other way that you can do it is, instead of using the log base 10, the common logarithm, you use the natural logarithm. Okay, and so that gives you the same answer, 1.425 either way. So either of these 3 ways is fine. Okay, in the end, we get the same answer, 1.425. So let's go ahead and go back to the thing, to the document, and that was 1.425 is the answer. Okay, number 7. Log base 3 of 1,242 minus log base 3 of 46. Okay, so we're going to use properties here. So this is a difference, so that means we're going to use this one right here. Except we're going backwards. We have this right here. We have one log minus another log. That should be, hey. Dang it. I'll have to fix that before the exam, for sure. Okay, so we put it back into that. So that's log base 3 of 1,242 divided by 46. Okay, now if you take 1242 and you divide that by 46, you get 27. So this is actually the log base 3 of 27. But we know that 27 is 3 to the 3rd power. And so this is just going to be 3. Because those match up. These are both 3s, so that means the answer is whatever's here, this 3. Or you could take this 3 out in front, and log base 3 of 3 is 1. So 3 times 1 is also 3. Okay, let's look at the next one as well. Log base 4 of 16 to the 500. Okay, so here you can pull the 500 out in front. You get that. That's from this row here, just pulling this 500 out in front. This C, this 500, pull out in front. And then 16 is 4 squared. So that means that all this is just 2. Okay, and so it's just this piece here, because these are the same. So the answer to that one is 1,000. Okay, and then this next one, you have the log of 10 to the 10,000. Okay, now this is log base 10 because it doesn't specify, so we know it's log base 10. And this 10,000 can come out in front, so let's go ahead and do that. So we get that. That's using the power property right here. And we know that this is base 10, so that means this is 1. So all this is just 1. So this is log of 10,000, but we know that 10,000 is 10 to the 4th power. So the answer is going to be 4. Okay, so I'm going to have to correct this every time now. Number 10, expand this right here. Expand the expression. Okay, so because this is times times times, then we can write this as log base 9 of 7 plus log base 9 of s plus log base 9 of t. Those are all 9s. And yeah, because they're all being multiplied. Okay, so that's the answer to the first one. This one, this is a natural logarithm, and it follows these same properties as well. This is a square root. So for the square root, we can rewrite the square root as the square root of AB as AB raised to the half power. And so then because it's a power, it can come down in front. So this 1/2 comes out in front here. And we're supposed to expand it out completely. So this part, we can use this rule here. The corresponding rule would be the natural log of AB equals the natural log of A plus the natural log of B. Okay, so this is going to be 1/2 natural log of little a plus the natural log of little b. Okay, and then distribute the 1/2 and we're done. Okay, now number 12. We're supposed to also expand number 12 using the laws of logarithms. This is a quotient, first of all, but this is the base 10, the common logarithm, base 10. It's a product in the numerator and a quotient, so we can just go ahead and write it like this. Whatever's in the numerator, you write with pluses, and then subtract the log of whatever's in the denominator, like that. So x to the 7th right there, y to the 8th, those are in the numerator, so they're plus plus. Z to the 9th in the denominator, so that's minus. And that's using these first two properties. And then we use the power rule, bringing the 7 down, the 8, and the 9 down. And this is gone crazy again. Oops. Come on. There's these buttons on the stylus. And when I accidentally press the buttons, then weird stuff happens. So I try to avoid pressing the buttons, but sometimes the pen rotates around and they press them. Okay, so let's look at number 13. Expand this one out. This is really weird. Okay, so first of all, you have a square root, so let's go ahead and rewrite the square root as x cubed. Let me see here. I'll write this other square root as also, and I'll write this other square root as is 1/2. Okay, so that's 1/2. This is 1/2, and then the last one's 1/2. Okay, so this 1/2 is this first square root. This 1/2 is this square root of y to the, oh, that's a 5 there. Oops. And then this 1/2 corresponds to this last square root right there. Okay, let's see here. So we have log of let's see, x cubed y to the 5th. So this is z to the 5/2. And that's all to the 1/2. And then the whole thing's to the 1/2. Okay, so now let me evaluate this. Let's distribute this 1/2 inside here. So y to the 5/2, z to the 5/4, all to the 1/2. Okay, now we'll distribute this 1/2 into everything. So that's x to the 3/2, y to the 5/4, and z to the 5/8. Okay, and then now it's all times, so it's going to be the log of the first one plus the log of the second one plus the log of the third one. And then use the power rule, this rule here, to pull the 3/2 down and the 5/4 and the 5/8 down. So 3/2 log of x plus, and then pull the 5/4 down right here. Wait, I lost the y. And then plus, and then pull the 5/8 down. Okay, and there we go. So that's the 13, right? That's number 13. So let's go on to number 14. Again, the properties, but I messed it up. And number 14, let's see, use the laws of logarithms to combine the expression. So we want to combine this into one piece. Okay, so usually the power thing is the last thing we do when we want to separate it. So when we want to combine, that's the first thing we do. So pull the 4 up first of all. So that's natural log of 2 to the 4th plus, and then pull the 5 up, natural log of x to the 5th, and then pull the 1/2 up. That's minus the natural log of x plus 6 to the 1/2, but we can also write that as the square root of x plus 6, like that. Okay, so now no coefficients out in front, or you could consider this as 1s as coefficient. That's a minus. Okay, and so then the next thing we want to do is combine these together. And this is log, so log. Put this stuff in the numerator. This is 16, by the way. So I'll go ahead and write it as 16. So the pluses, put those in the numerator. The minus, put that in the denominator. And there you go. That should work out right there. Number 15, the same thing. You want to combine into one expression. So again, the first thing you do is pull these 3s up. Pull these coefficients up. So that 3 goes up to there. This 3 goes up to there. Five goes up to there. You could actually pull, if you wanted to pull a -5 up and have a plus, you could do that. So that would be plus, and that would be -5. That works too. And then everything that's plus goes in the numerator. So x cubed, y cubed, because those are plus, x cubed, y cubed. This is minus, so that means z to the 5th goes in the denominator. Now, if you'd pulled this up to -5, then you'd have a z to the -5 in the numerator, but then that should go down there as a z to the +5. Okay. Oh, hold on. I made a mistake. Here, hold on. I'm going to fix it though. Okay, this one, this 3. Notice that there's these parentheses here and here that I didn't realize. This 3 distributes to everything. Okay, so I messed that up. Okay, so I should get 3 log 6 of x plus 9 log 6 of y minus 15 log 6 of z. Okay, so that means that this should be a 9 right here, and this should be a 15. Which means that this will be a 9, and that'll be a 15. Okay, there we go. So that should be better now. Okay, number 16. Okay, so 1/4 log. Okay, so we're supposed to combine this one as well. So this 1/4 comes up, and 1/4 times 4 is just 1. So this is just going to be log of x plus 3, the first term, because 1/4 times 4 is 1. So that just goes away. Okay, now this one, let's see. Let's distribute the 1/3 in so we don't get into trouble like with the last one. So I'm pulling a 1/3 into here and into this term and multiplying by this term right here. Okay, now, okay, this 1/3 goes up here. So 1/3 times 6 is 2. And this 1/3 goes up here, and that's 1/3 times 3 is just 1. So it's just log this. Now combine everything. These are pluses, so they go in the numerator. This is a minus that goes in the denominator. And if you leave it like that, that's fine. That actually, you could, I'm not sure if this will work though. So here's the numerator. The denominator, this right here, factors into this. So I guess you could cancel those off. Let me see if that works also. In the if you put that into Webassign. Yeah, that works. So It also works as an answer. Okay, and then finally, last one is log base 7 of 2.89. And we're supposed to use the change of base formula, so that's this last one here. So that would be, you can use common logarithm, which would be the log of 2.89 divided by log of 7. So the log of the x would be 2.89, so that would be here. And the b would be 7, so that would be here. And then the a would be 10 in this case. Or you could, if you're feeling, so here's the thing, if you're feeling common, then use this one, because that's the common logarithm. If you're feeling natural, then use this one. This is the natural logarithm. So either way. Let's go ahead and go to GeoGebra and do it there. I'm not, and you know, or if you just want to put this in, that's fine too. I have nothing against that. And there's no way of telling which one you used. Okay. So again, you could do it. There's 3 different ways. This is the common logarithm, and this is just using the base that's there, and then this is just the natural logarithm. So, so common logarithm, log of 2.89 divided by log of 7. That's the first one. So 0.545378. They want 6 decimal places. Or natural logarithm, if you're feeling natural. That one is the same answer. Or if you're just feeling like, okay, I want to use some technology to do this, and ignore the instructions, do it my own way. So put underscore 7, right arrow key, parentheses, 2.89. Boom. So either way. So any of these ways. So the answer in all 3 cases is 0.545378, because that's 6 decimal places. The second 7 is this represents the 6th decimal place, but there's a 9 there, so that's round up to an 8. Okay. So approximately 0.545378.